What up, everybody? Welcome to another episode of Let's Ask Paul. My name is Paul Abernathy, your host as always, and welcome to the podcast. So if you've never listened to the podcast before, this is a podcast over at paulabernathy.com where you can submit your questions to me via the online portal. It's simple. You just put your name in, put your email address in there so that you get notified, and you just put in your question, click that submit button, easy peasy. Just like that, your email comes to me, it gets put in a nicely placed folder, and I get to answer your questions, either via email or, if selected, on an upcoming podcast. And that's what we're doing today. So if you've never been here before, you're in for a treat. We got a couple we're going to pick up today that are asked to us through the portal, and we think you'll learn something from it. So learning something from it. How'd I say that? Anyway, I get a lot of jokes from people because I speak really, really fast, and sometimes my words jump together. I get a lot of that. I get the hate mail. I do. I get the hate mail from people. I'm just saying. Yep, that's what I get. Bunch of that. All right. So everybody, welcome for joining me on this episode. This episode is sponsored by electricianpride.com. If you haven't checked it out before, we have some neat hats over there to show off your pride as a master electrician journeyman. Now, I'm going to tell you that a lot of the stuff over there is a little more pricier, but it is very specific to your trade. But a lot of the stuff is print on demand. So again, we use our graphics and our designs, but it's print on demand. And a lot of the stuff is embroidered. It's really, really nice embroidery. I mean, they're all well done hats, high quality snapbacks, not the cheap stuff like trucker hats, things like that. You know what I'm saying? None of that kind of. No, none of that. These are all high quality stuff. And so, we've been having a lot of people been buying the little baby onesies and stuff with the master electrician on them. That's cool. A bunch of different stuff. So, but the most popular right now, as I speak, is got to be the master electrician and journeyman electrician snapbacks. They're available in all different colors and whatnot, but that's probably, it's just a neat hat to have. If it says master electrician on it, journeyman electrician on it, just one of those neat hats to have. So if you got some time, just do me a favor, go check it out over at electricianpride.com. All those proceeds help go back into the show and help us grow. Some of you might be aware, we are moving into a new facility come February 2023. That's right. Thanks to everybody. All right. That's enough of that. Thanks to everybody who's helped this grow. I think you recently saw that so far already in 2022, Master the NEC podcast has already eclipsed 1.1 million downloads. Now, that's not all my other podcasts. That's not Let's Ask Paul. That's just Master the NEC podcast. So I have multiple podcasts going all the time. But that one I'm, really proud of because it's over 612, I think, actual podcasts. It's a lot of episodes. So we're excited about that. All right, so let's get into tonight's episode and see what we got going on. The very first one that we got up on the slate here says, Paul, what is the difference and when to use 31015B1 and 31015B2? Okay, so let me paint the picture out there for you. So you've been in the code for years and you're probably looking at a situation where you have an elevated ambient temperature other than 30 degrees Celsius and 86 degrees Fahrenheit. I mean, that's what's in table 31016. That's the ampacity table. If you ever looked at it, you notice that all those ampacities there that we're used to working with as an electrician, all of those are based on a perfect world, 30 degrees Celsius, 86 degrees Fahrenheit. And all of a sudden, you do an installation and it thrusts it into an environment where it's not one of those perfect worlds. What do? Well, you got to know how to adapt, right? You got to know how to do a ambient correction. If you got more than 3 current conductors, you got to know how to be an adjustment's got to take place. And hopefully you know how to do that. If you don't, then let me tell you, commercial warning, you need to get our Fast Tracks program because that's fundamental for electricians. Fundamental. I like the fun part of it. I'm just saying. Y'all like that? No? Okay. Anyway, that's enough of the cricket. But I love calculations, and I love the concept of calculations, and I like how we wrap your head around the calculations. And I will tell you, sneak peek, we're going to be going over a lot of things in the 2023 code. Whether you're on the 2023 or not, I think it's really important for you to wrap your head around it because you get to see what's changing. And the quicker you see the changes, because you're already familiar with whatever code cycle you're on, right? The more you see the changes and more you get a feel for their intent or why some of the changes were made, it's going to make you a much better, well-rounded electrician. So we're going to be doing some episodes on the 2023 so we can even break it down even more. And I will tell you, Article 220 has really been spun around here. Things have been shifted around and all this type of thing. So you're going to have to used to how things look differently in Article 220. It's not a bad thing. Trust me. It's a good thing. They did a good job. All right, let me get back to this. So you got to make a ambient correction if you're dealing with an installation where the portion of your wiring method, let's say, is going to go through a location that's going to have something other than 30 degrees Celsius, 86 degrees Fahrenheit. But what you'll notice is that when you go to do that in 31015B1, you'll also see a 31015B2. Now, B1, you'll notice that if you go back and look at the information for table 31016 and 31017, since those are based on 30 degrees Celsius, 86 degrees Fahrenheit, that 310.15B1 is also based on that information. And for all intents and purposes, in the real world, in the field, you'll probably never use 310.15B2. However, you do need to know that 310.15B2, that's dealing with 40 degrees Celsius applications, and that does come into play if you're using 310.18, 310.19, 310.20. A quick check for you is if just go into your code book and go look at 310.16.17.18.19, things like that, and you'll notice that 16 and 17 are based on 30 degrees Celsius. 18, 19, 20, all those are based on 40 degrees Celsius. So there's some people out there that'll say, well, you know what, Paul? You just take a pen and you just mark a line right through. Oops, I'm dropping everything in the office here. You mark a line straight on through 310.15B2. And I'm the opposite of that. I tell you, you should never do that. The reason is because if you're preparing for an electrical exam, that's the last thing you want to do. Why? Because I can bet your butt that the moment that you do that, you're going to get an exam question based on it. I'm just saying. But if you go look at 310.16, 17, 18, 19, and 20, you'll notice all those are based on 40 degrees C, 104 degrees Fahrenheit. So for me and you, everyday electrician out there working in the field, you're going to spend more time on 310.15B1 than you definitely will ever in your career on 310.15B2. Okay? So I don't want you to mark it out, but I'm telling you, you're pretty much for normal electrical installations, normal ampacity values, when you're doing a correction, ambient, you're going to go to 310.15B1. Okay? Hopefully that answers that question for you. But look at your code book. You'll see how it's laid out. Pretty straightforward. Easy peasy, right? That's right. All right. Good question. Let's go on to the next one. We're knocking them out. Okay. Now, the next question looks like this looks like I've answered this question before, but it's getting asked again. And like I said, I want to do my best to answer everybody's questions. So I'm going to make an attempt to do this here. And this one is actually probably, I don't know, I'm thinking it's jumping the gun a little bit. So this is a question about the looks like 2023. And it's asking about 210.8D. So I think I've answered this before, but I'm going to go on and do it again. Hey, Paul, Love your podcast. Been listening to it for years. In fact, I've listened to you all the way back when you were the electrical guru, when you were back in Richmond, Virginia. Thanks for all you do. I feel we all become better electricians by listening to you speak. Well, that's quite nice. I don't know that I've had anybody ever say it that way. Anyway, he goes on. He goes, my question is it true that in the 2023 National Electric Code, well, it's electrical. That's my pet peeve. We call it electric, but it's National Electrical Code. But anyway, the guy just said neat things about me. So I can't correct his grammar because I know my grammar sucks. Sorry about that, fellow. Okay, anyway, he said, where was I at? Oh, he said, I noticed, is it true that electric ranges are going to require GFCI protection in the 2023? What caused this to take place? Thanks in advance. Okay, good question. I think I have covered this before, but in the effort to be all expansive, I'll cover it in a little more detail. So for those that are listening, this is not a surprise. I actually did a podcast on this, a video. I actually did a video that's available over on our YouTube channel of the 2023 changes for 210.8. And I covered this, and I'm assuming this person didn't watch that. I encourage you to go watch it because I kind of go deeper into some of these things. But absolutely, we have to understand the structure. 210.8a is... When you're looking at it, 210.8a is basically your dwelling unit applications. 210.8b is other than dwelling applications. Give you a little laundry list there. 210.8c is the crawl space lighting outlets down in the crawl space. And D is specific appliances. So the code says GFCI protection shall be provided for the branch circuits or outlet supplying the following appliances. Noticing now that this is slightly different than what's given to you in 210.8a, right? And B, right? That's very receptacle driven. So just when you start, we're getting ready to look at, you start thinking, well, is this receptacle driven? And the answer to this is no, it's not. An outlet, all it takes is to go over to Article 100 and look at the definition of outlet. You know that we're not talking about a receptacle here. That's a device. All right. So it's the branch circuit, which would be supplying the range, and the others that we'll look at here. But that's the branch circuit or the outlet. So it could be, for example, you have a cooktop and you bring your branch circuit to a junction box. All right. And that's the point where you're going to take the power from it to supply the appliance, and that's the outlet. Okay, so you only have to look at the definition of outlet to get a concept of what we're talking about here, and not to confuse it with everybody's notion that an outlet is what's in the wall that you plug something into. That the device, receptacle device, is what I plug an attachment plug into, like a cord, and I plug into that. That device goes in an outlet box. Okay, so if the device wasn't in it, that would be an outlet because that's where we're going to get the power from. Right? All right, anyway, enough of that. So if you're confused at that, go over to definitions, and you're going to notice in the 2023, if you happen to be in the 2023, if you're starting to do your research now and learn a little bit, you're going to see that every definition now has been moved to Article 100. So it's gotten huge. Not a bad move. Keeps everything in Article 100, so not too bad. Kind of get used to that because you know that throughout the code we had the .2, which were definitions that were specific to that specific article. And now everything just gets moved to 100. So I think it's a good place for it, and I think it's not a bad move. So again, uniformity is what we're after, so I have no problem with that. So this is dealing with specific appliances. So I'll read it again in its entirety so we can wrap our head around it. Then I'll just run over them real quick and answer your question. GFCI protection shall be provided for the branch circuit or outlet supplying the following appliances rated 150 volts or less to ground. So the first person that asked me, well, aren't ranges 240 volts? They are phase to phase or line to line, but line to ground, they're 120. Okay. But it also goes 150 volts or less to ground and 60 amperes or less, single or three phase. So 3-phase is not going to get you out of this one. Okay. 120, 208. Well, 1-phase to ground, that's 120. So that's going to be 150 volts or less. So it is going to encompass that, right? So here's what you've got. And also remember, this rule here in 210.8D is not dwelling specific. This is just in general. Commercial, dwellings, either or. It's all inclusive. And there's 12 items here. Number 1, automotive vacuum machines, whether they're private or public available, doesn't matter. Number 2, drinking water coolers and bottle fill stations. Had to get those bottle fill stations in there. When I used to go work out at the Lifetime gym, where I got kind of soft and flabby. Yeah, that's what I said. And that would be, they would have a bottle fill stations. Usually it's filtered water and all this kind of stuff. So anyway, GFCI protection is going to be required. Number 3, high pressure spray washing machines, public or private. It doesn't matter. When I say public or private, I mean, let's say you have it and it's available to the public or it's not available to the public. It doesn't matter. Tire inflation machines, same concept there. Vending machines. Now, we don't have a definition of vending machine anymore, but there is a standard for vending machines. So you got to go look. And I haven't checked. I don't think the definition made it back in the NEC. Somebody go check that for me. I don't think it made it back in there. Supposedly, we know what a vending machine is. I tell you what I think a vending machine is. You put something in, you get something out. And I used to think that a slot machine in Vegas was a vending machine, but I spent more time putting things in than I did actually getting things out. Yeah. All right, so vending machines, sump pumps. Hey, sump pumps. Now, that's not new to 2023, by the way. For the guy that was asking, who submitted this, that's not new. And I know we haven't gotten to yours yet, but that's not new. And I have people, I tell you, over on the TikToks and the Instagrams and the Facebooks, a lot of those social medias, man, you tell them you put a GFCI on a sump pump circuit and they cringe, buddy. They're like, you do what? I'm like, absolutely. It's, you know what? Water can be pumped out. I mean, I grew up in a house with a basement flood every time it was a major storm. So I'd much rather have to pump the water out than have to worry about going down there and getting shocked because I got to get down there to do something down there. I'd rather have the power out. We can pump the water out, So I can listen to everybody's argument, but I don't really care. Sump pumps, GFCIs don't just trip randomly like they used to anymore. Something's usually wrong or something's going on that causes this leakage current, something. So, I mean, we've installed these things now for, since 68 or something. So, I mean, get over it. The next thing is dishwashers. Yes, dishwashers. Now, that was the same before, but dishwashers are required, whether it's dwellings or other than dwelling. Okay, so here you go. Here's your question. So, electric ranges. Now, some people say, well, yeah, but you're going to plug it into a receptacle. Where are you going to find a GFCI receptacle? Well, you're not. You're going to have to do it back at the circuit breaker, obviously. Doesn't that make the circuit breaker manufacturers happy? That's enough of that. All right, so, but, even if it was a receptacle style, it wouldn't be readily accessible anyway, right? Usually down there under the drawer, whatever you call it, wherever you're from in the country. The next thing is wall-mounted ovens. Next is counter-mounted cooking units. Slang would be cooktop. It's going to have GFCI protection now. And I can hear people now. Because, is that going to raise the cost and things? Abso-freaking-lutely, is it? Is it going to put more GFCIs in the panel? Abso-freaking-lutely it is. Now, of course, your state could amend it. We know that. I hear that all the time. Every time I post something on social media or wherever I post something, I always go, people, not in my state. Well, you got to remember that I'm talking all 50. I'm talking general. I can't get hyper focused on any one state, nor do I desire to be hyper focused on you. That's your job. You know your state. I'm just the messenger, my friends. And so, yeah, wall mounted ovens, counter mounted cooking units, GFCI protection, clothes dryers. Okay. We kind of had this in the 2020 if you had to put it in a basement, because you know what changed in 2020 was finished or unfinished basements of a dwelling. They had to have GFCI protection on. So this was kind of already a thing. And of course, if you had it in a laundry room, it was already a thing. So it's still here. That's okay. But it's a thing. So you got to make sure it's GFCI protected. And of course, microwave ovens. Absolutely. So yeah, the neat thing, well, I shouldn't say neat. Let me rephrase. Let me back that up. The unique thing about the change in 2023, and I know I'm going off topic for the question it was asked, and I didn't want this to turn into a code change episode, but the interesting thing was that in 2023 in A, which is dwelling units, they now switched to kitchens. And it's no longer GFCI requirements just for those receptacles that serve the countertop. Now it's all receptacles in a kitchen. And so if your receptacle for your garbage disposal underneath or whatever, before even was within 6 feet of the sink, it doesn't matter at this point. It's a receptacle. It's in the kitchen. It's going to get GFCI protected. That receptacle that's above the, that's going to the microwave maybe, cord and plug, it's going to be GFCI protected. So everything in your kitchen is GFCI protected. Okay? That's just where we're at. Now, there's some exceptions, and they now move the exceptions to the end, but nothing's going to take you away from that requirement. Just saying. All right, anyway, there you go. So those are your 12 items. Hopefully that answers your question. Shameless plug, I will be doing quite a few live streams on the changes to 2023. Of course, the interesting about when I do them, I just don't show images and graphics. Usually I show the code and then I explain it. There'll be a lot of code change books coming out with graphics and illustrations and things like that to kind of visually help you. I find it easier for me and more of a challenge to be able to paint you a mental picture. So mine's just a little different. It might be good for you. It might not be good for you, but I appreciate you watching them. And there's always that one guy that thumbs down. I know who you are. And I appreciate you wasting your time listening so that you can give a thumbs down. Because ultimately, at the end of the day, you're the loser that listened the whole time so you could put a thumbs down. I know. I gotta let that go, right? Okay. Anyway, so hopefully that answered that question for you. And we will go on to the next question. I will see if I can answer another question in this episode of Let's Ask Paul. All right, let's see what we got here. It says, "Hey, Paul, love the podcast. I got a question for you that should be right up your alley, as I understand that you're a member of Code Panel 17. That's true. That is true. And I'm not the principal, but I am the alternate on it. Okay, what's the question? I heard through the grapevine that the copper grid that was introduced in the 2020 will be disappearing in the 2023. In fact, I also heard another rumor that the copper ring, the method that we've been using for years around the perimeter of your pool, may also be disappearing in the 2023. Can you shed any light on this? Thanks in advance." Okay, another 2023. People are intrigued by the 2023. I don't know. I can tell you that it was another session that we did where it was remote. We didn't get together. We didn't have the meetings where we could discuss things. It was all done on Teams, Microsoft, and yeah, just, not the preferred way to do it. I like to see people eye to eye so that if they're talking BS, you can see their eyes fill up with it. You know what I'm saying? So at the end of the day, great question. I will answer this two ways really quickly. Number one, The copper grid, and this was the allowance that was added in 2020 based on studies that were presented to Code Panel 17, whereas you had a copper grid that went out 3 feet around the perimeter of the pool. We're talking about perimeter equipotential bonding requirement, right? In 680.26. I guess that's what, B2, right? That's the perimeter. And so we added that to it because the studies show that that was the best way to do it. In fact, we've already allowed these copper grids to be under a conductive pool shell that, for example, may have been encapsulated rebar, and it was concrete. So it was a conductive pool shell, but didn't quite qualify. So in other words, you had to put the grid underneath it. So we've done that for years. That grid has been around. It's just copper, right? And it's really reliable, and we've been there. We have a history of it. So when it came to perimeter surfaces, it was introduced in the 2020, and it is probably the best you can get. And the studies, to me, and when I sat through them now for multiple cycles, it was very much justified. And of course, it's in the code. So obviously, everybody voted on it, and it got in the code. And it pretty much tells you how to create this grid in accordance with 680.26B1B3. Tells you how to do it, 12 on 12 inch, 3 feet out, all around the perimeter. So it kind of tells you how to do it. And it's very reliable. But what was trying to be done, I guess, is what they're probably alluding to, was during that whole time, the copper ring version, and that's where you have the solid 8-gauge bear that runs around the perimeter of the pool. And if it was a conductive pool shell, okay, then you would connect it at 4 corners. And any metal that would be within 5 feet would be bonded to this in order to create this equipotential bonding plane so that you don't have any differences of potential, no step potentials. Okay, you raise everything up to the same. And if you raise it all up, you're not going to feel a difference. And that's how we get shocks. We have differences of potential, right? So basically masking it. Anyway, so it was funny during the code panel hearing for 3 cycles now. We've never, ever really found out where that copper ring came from. Now, I've got my opinions, and my opinions think that it's comes from the pool and spa industry, who simply want an easy, cheap way to put something in, yet still charge you $100,000 for a swimming pool. I'm just saying, you know. So at the end of the day, it was put in. Now, recently, there was a study that was done. And it was done in, they came and presented this information, additional information at the Standards Council. I think Fred Hartwell was there. If you don't know who Fred Hartwell is, Google the dude. The dude's amazing. He also writes the NEC handbook, not the one from NFPA, but the one that comes from McGraw-Hill. Great book, by the way. Everybody should have one of those in your library. It's worth the investment. I'm telling you. The dude's sharp. This is probably Fred's last cycle because he's getting up there in age. But boy, are we going to lose a great mind? Because the dude is just amazing. I don't think he's ever wrong. But he's really methodical in how he does something. And sometimes he rubs people the wrong way. But that's okay. That's just Fred. And he's just an intriguing guy. So if you get a chance, get that book before, I guess, he's not going to write another one. I don't know if he's writing one for 2023. I guess he is. But I can't expect it to be any good after he stops writing it. I'm just saying. Anyway, they're out there for the 2020. It's great to have in your collection. McGraw-Hill puts it out. So anyway, he helped them present some of the data recently because there was some deaths. There was some injuries that occurred from a single copper ring around a pool. And their test that they have done and that was done and presented, multiple tests were presented showing that it's just not effective, although industry still allows it to be done. And it's still going to allow it to be done because the 2023, we failed as a code panel to get rid of a copper ring, and tell people to put in a copper grid. But it's not even about using the copper. You with me? It's about what we know is test data. There's test data for this copper grid, and we've had it for years with the conductive pool shell underneath one by putting in a copper grid as an alternate method to encapsulated rebar. But we had enough data, but nobody could ever present any real findings for the copper ring. How did it get in there? And why is it 18 inches to 24 inches from the inside wall of the pool? And is that enough surface area to dissipate the issue with stray voltage? And the answer to that is no. And the study said no. And I sat right there. So if you say I don't know what I'm talking about, I sat through every presentation from these experts that this is what they do. And then all of a sudden somebody said, well, you know, the only reason they want to get it in there is because there's one guy that makes that grid. Dude, anybody can make that grid. All it is 8-gauge copper overlapped, spot welded. And the fact of the matter is, the interesting thing is, one of the methods that you're allowed to do around the perimeter of the pool is what's called structural reinforced steel. Doesn't necessarily mean rebar, okay? It could be just a wire framing mesh that's in the concrete around the perimeter of the pool, right? And that would be considered, quote, structural reinforcing steel. And with all these deckings that are getting put in now with fiberglass, then you have to have something, whether it's the ground ring now, or you have the grid, or whatever. But in order to construct that perimeter, I mean, in a lot of cases back in the day, we just turned that rebar up and out 3 feet and good to go. Perimeter around, 12 by 12 squares, 3 feet out. And that was it. So you can still kind of construct the concept and do this structural reinforced steel. You can use metal steel meshing as long as it's adding reinforcings to the decking. Remember, we're not talking about the pool here. We're talking about the decking. We're talking about this perimeter surface. Anyway, you have options, and that's probably the cheapest option that you would have to do it that way. But at the end of the day, there was enough data that was submitted, and you just, for some reason, and you had one guy, and I'm not being mean. I'm not going to be mean. But you had one guy fight against it, but all you got to do is go look and see what his interest was. And I'm just saying. But at any rate, in the squeakiest wheel sometimes gets the grease. And so it didn't make it. But this is one of the ones where I say code panel 17 kind of missed the mark. Because I often say, and I'm going to remove myself from this because I'm not the principal, but our principal didn't vote for it. I will say anybody gets hurt down the road after we've been presented all this information and somebody dies, then it's on the hands of the code making panel 17 that made that choice, and all that data was right there in front of them. We could have prevented this from happening. And I know that's harsh, and I know I'll get some flack for that, but I'm like, dude, I'm telling you folks, the paperwork was presented to the code panel. We saw it. We read it. It was real substantiated data. It wasn't rigged data. It was based on real studies, real incidents. And then when they said, well, we don't have the bodies, they turned around and presented cases where there were the bodies. But, it's just amazing to me. I don't have a problem with using the steel mesh. I don't have a problem with using rebar. I don't have a problem with using a copper grid. I have a problem with the copper ring. If I built a pool today, then I would be putting in the copper grid, or I'd be putting in rebar, or I'd just roll the steel fencing mesh around it in the pour, and that would be my equipotential bonding grid. And when it comes to the copper, we're only talking about $400 or $500 more to put a copper grid in. It's not what you would think, what people want to make you believe, but it's a better, safer pool. And anytime I'm going to put my family in a pool, I want it to be safe. Same reason I won't do, listen to me, folks. This is just me talking. Same way, if I did a pool, I would not be putting 120 volt lighting in my pool. I would be putting low voltage lighting in my pool. I know what you're saying. Okay. I'm just telling you what I do, and my opinion counts for this podcast. But you could do you and whatever makes you feel good. All right. So hopefully that answered your question. No, the copper grid is still in the code. No, the copper ring did not get removed. You still have 3 options here. They're the alternate options, okay, that you can use for this perimeter surface, okay. And nothing else changed when it comes to things. That's nothing else changed there as far as that goes, okay. All right. Hopefully that answered your question. That's a great question because there were rumors around, and it did make it all the way up to the Standards Council trying to get this ring removed and the grid solidified, because there's a lot of people that are passionate that grid, they can't even point to how it actually got in the code. There's a story behind it, but there was no real technical substantiation, and that's what you're supposed to have when you get stuff in the code. Technical substantiation. At least something that makes you scratch your head and go, something's not right. We need to do more testing. Okay, well, these folks did the testing multiple times, and all the data proves that the ring doesn't work. The grid does work. So whether it's a steel mesh, whether it's rebar, whether it's copper grid, those work. And one of the things that's kind of funny is that we did this years ago in 547 for cattle, for equipotential bonding. It's good enough for cattle, but it's not good enough for people. We don't put no ring around anything for 547. We put in a grid because we know that it works. I guess it's okay for cows, but it ain't okay for people. Whatever, okay? I guess that's where we're at with that. All right. Let's see here. Do I have time for one more question tonight? Boy, there's a lot of 2023 questions. So anyway, is there another one? Let's go on and look and see if we got another one that I haven't already answered in an email. Let's see what we got. Okay, this says, okay. Now, okay, we'll end on this one, but this is more, a little more personal question. Hey, Paul, love the podcast. Love to catch the videos. Sure wish you did the videos on YouTube that were free rather than having to pay per monthly subscription. Hey, sorry about that, but daddy got to pay the bills. I'm just saying.
Daddy's gotta pay the bills.
All right, so the question is, hey, it's the least you can do. Say thank you for all the content, bruh. You know what I'm saying? Anyway, the question is, let's see here. I got to get to the root of the question. Okay, it says, Paul, I've heard you say on other podcasts that you have trademarks and patents. I understand your trademarks are on the CMECP and Fast Tracks. What are your patents? Thanks in advance, and look forward to the next podcast. Okay, great question. Not technical for those out there that say, okay, here goes Paul. Dude, I'm just answering the questions, and it's a good question because people want to know. I actually hold 4 patents. 4 patents. 3 of them are on MC cable, and one of them is on what's called a hybrid cable. So when we say MC cable, my patents are on, I'm sure you've heard of the MC PCS. That's power, control, and signal. That is the MC cable that has the 0 to 10 low voltage lighting in it. Right? So I have what's called their mutual patents, means that there are 3 patents that we have at Encore Wire, and I'm the chief person. I'm the one that came up with the idea years ago. But we have other people that helped in the design, in the research and all that, and they get added to a patent. Those are, from technical standpoint, it's my patents, all 3, on different phases of that, we like to say, MC PCS. Okay. Now you might hear it as MC LED from Encore. You might hear it as MC Duo from Southwire. AFC has the one called Luminary Cable. But originally, all of those patents were mine. No enforcement of it, just kind of letting everybody do their thing. We're not fighting it. We don't have a problem with it. In a world where everybody wants to fight over patents, we don't have a problem with that. It's just, To me, it's just another product, but we did get the patents for that. And I have 3 patents for that. Now, the one that I'm most proud of is called a hybrid cable. Now, it's designed to be both a tray cable, so it meets all the rules of UL 1277, but it's also an SE cable, service entrance cable, so it meets all the rules of UL 854. So the benefits of that cable is that it can go outdoors on the side of a building like SER can, service entrance round. It can go outside underground like tray cable. It can go inside of a building just like SER. It can be run through the building just like SER. It can transition from indoors to outdoors on the side of a building like SER, which tray cable can't, by the way. And then once it gets down and go into the ground, it picks up all the attributes of tray cable. So it really is a hybrid cable. So no longer do you have to transition, put junction boxes and transition from one to another, go through your attic and put a junction box to switch over from SER to PVC jacketed MC, which you could do and run that down in the ground. But you could just come straight up, straight through, straight out, straight down into the ground, over to the building, come up, hit your disconnect at the building, bada bing, bada boom, bada bang. So that's what I came up with. And the reason I came up with the concept was because we slowly were expanding tray cable, which, to be honest with you, tray cable is really just a glorified SER. Anybody that tells you that, oh, it's only for use in industrial, they can only say that with a straight face because they don't understand that the inner conductors that are inside of the cable are exactly the same, whether it's SER or tray cable. It's exactly the same. Okay? So if it's THHN, THWN-2 in your SER, then you get your hybrid or your tray cable with THHN, THWN-2 inside of that tray cable. It's the same thing. So the inners are the same, right? The only difference is with the SER, you have a fiberglass binder that wraps around the conductors, right? Gives rigidity to the product. And then it's extruded with a jacketing, right? Well, with tray cable, it's you don't necessarily need a binder. Now you can if you want to keep roundness so the extruded sheathing does not drip down in the interstices and kind of look kind of triangle, and you're trying to keep it as round as possible. But it doesn't really need a binder, although you could put one in, but it doesn't need one per the UL 1277 standard. But if you want, you can if it keeps the roundness to it. So when you create the hybrid, you're basically taking all of the attributes of SER and all of the attributes of tray cable, and you're putting together in one. And that way I can magically pick up its use and application for both properties, depending on how I use it. The other interesting benefit, and I don't want to spend a lot of time on this, but the other interesting benefit with it is that most of the time when it's being used as tray cable, you're not going to terminate it. That's outside, underground, whatnot. It's when you come out of the ground and you go into a building, you need to terminate it. Well, finding a fitting for tray cable can be a challenge. But with this, it transitions between tray cable and now all of a sudden it's SER. So you can use a standard SER fitting. Now, the only difference with the hybrid is that it's got the attributes of SER. The hybrid picks up the conductors, it picks up the fiberglass binder. And instead of having a 30 mil thickness extruded jacket over it all, it has roughly a 60 mil. Now, that's a lot thicker. So it can be subject to places that normal SER probably wouldn't be. It would be ripped or stretched or damaged. So it's a more robust product. So you get all those extra benefits. And I will tell you, it's only available from Encore Wire. So check that out if you're interested in that product. It's got an amazing possibility for use in that type of product. So again, I'm happy. And I am the only one on that patent, one, because nobody else believed in it but me. So that's right, I said it. I was the only one that believed in that, and I fought for that thing for about 5 years. But it's out there on the market. Check it out. It's a great product. It's my baby. I am very proud of it, much more than the MC stuff. Everybody does MC, but this was unique, and I did it to overcome two hurdles. One, we couldn't get the expanded use of tray cable. Code Panel 6 could not get it through their head that the use of tray cable should be broadly used. And they keep saying, well, that's for industrial. And I'm like, wait a minute. If you're saying it can be installed in an industrial building because it's, quote, tray cable, but you're saying it can't be installed in a residence when it's thicker sheathing, but it's the same inners, it's the same as SCR, but it's more robust. But you're saying it can't be in a dwelling, but you're saying it is okay to be in an industrial environment where it is subject to more roughness and how it's treated. And they go, yes, that's right. I'm like, okay, whatever you've been smoking, please stop sharing it around the table, because that's, it is all it is SCR on steroids. That's it. So anyway, that's my spiel for that one. So hopefully you got something out of that. Well, I'm going to call it a night tonight for this episode. Hopefully you got something out of it. It's been a good episode, but I will do some quick shout outs to all of my members over on the Fast Tracks. Again, we're so excited. We would not be moving into our new facility in February if it was not for our students, not for people that subscribe to our monthly and annual, for buying our stuff on Electrician Pride, who believe in us and really like this education. Over the last couple months, we've been a little slower than normal with the videos because a lot of stuff going on, but we're getting back in track. And everybody knows I've got hundreds of videos out there. So you know that I'm used to putting out the content. Well, we're going to be putting out more. And again, I owe it all to all of our members. Again, collectively, it's just an amazing thing to have people out there who really do care about helping us succeed. It means a lot to me. So I do thank you all out there, those that go over to electricianpride.com and pick up a hat or something. We make very little on that. And by the way, you buy a hat, we make about $4, $5 on that hat. That's it. So again, it's just the cost of those type of printing or embroidery. It is, but every little bit helps, and we appreciate every bit of it. Anyway, to everybody out there, God bless. Thank you for helping us, and hope to catch you in the upcoming episode of Let's Ask Paul. Until next time, stay safe. God bless.